dx squared is equal to m as a function of x. Okay. This is what we mean by we will apply the elastic curve method. Okay. So m as a function of x, we can determine already, right, from here. Right, we can get m as a function of x. Okay. So what I'm going to do is I'm going to use the same example and we are going to incorporate these values. Okay. So we are going to use the example that we used before. We're going to use this one. Okay, we're going to use this one. I will copy the diagram over here. Okay, we'll come here, I'll paste, don't move it. And then we will come to this equation over here. And come here. Seriously, come on. I'm getting so pissed off with Microsoft Words now. Okay. I think it's basically you cannot jump the page when you do it. I don't know. I give up. You know what? There's a way to bluff the system. And if I picture the whole thing, it won't work also in the picture. Stupid thing. Okay. Okay. You know what? Fine. Okay. Now we are going to form, right? We're going to form two more boundary conditions. Okay. So we have V M theta Y. V M theta Y. We know that an x is equal to 0, v is equal to 0, m is equal to 0. Theta, we don't know. Y is not equal to what? 0. Okay. Let me write out the boundary condition first, then I explain what is going on. Over here, we know that theta is equal to 0, y is also equal to what? 0. Why is that? Okay. So if we look at the deformation pattern, okay, if we look at the deformation pattern, the structure will deform this way. Okay, the structure will deform this way. Okay, in fact, at this end over here, it should be flat a bit. The structure will deform this way. Okay, so we know why the display at this point over here at point B, right? Y is equal to 0 because it did not move. Yes or no? The slope, if we were to draw a straight line, right? This is how we determine the slope, right? The tangent. So all these have theta, yes or no? All these have theta. But when it's 0 over here at point B, theta is equal to what? It's equal to 0. No need to memorize. There's nothing to memorize over here. You see it physically. That's why you guys are mechanical engineers or civil engineers. Nothing to copy or memorize. Okay. So with this, that's why we can form two more boundary conditions. Okay. So how do we proceed from here? Okay. How do we proceed? So we are going to apply the elastic curve method where, right, EI d squared y over dx squared is equal to m as a function of x, which is equal to y minus 1000 x cubed over 3 minus by 3000 x squared. Okay, so now we want to find, right? So this is our equation number 3. Okay. So from here, we are going to find EI dy by dx, which is also equal to EI theta. Right? So that's why I make you all memorize what? V M theta to what? Y. Okay. So from here, you integrate minus 1000 x cubed over 3 minus 3000 x squared plus by C3 dx. Oh, no, C3, sorry, dx. Okay. So this will be equal to minus 1000 x4 over 12 minus by 1000 x cubed plus by what? C1. Okay. And this is going to be your equation number 4. Right. So minus 1000 x over 12 minus 1000 x cubed because divided by 3, 3000 divided by 3 plus by C1. So now you can use your boundary condition. You can use this boundary condition. Right? We are going to substitute when x is equal to 6, theta is equal to what? 0. Okay. So we're going to substitute into equation number 4. Right? So it's equal to 0 is equal to minus 1000 times by 6 power of 4 divided by 12 is 108000. Let me do it again. 6 power of 4 times by 1000 divided by 12, 108. Yep, minus by 1000 multiplied by 6 power of 3, 216, 123 plus by C1. Oh, sorry, C3. I should not call it C1. C3, sorry. C3. So C3 is equal to 108123 plus a 216123 is equal to 324123. That is our C3. Okay. So now we know that EI theta is equal to minus 1000 x4 over 12 minus by 1000 x cubed plus by 324123. Okay. So you integrate again. I told you guys it's not difficult, right? It's forming the initial equation that is difficult, not difficult. You have to remember stuff. And you have to remember the what? Boundary what? Conditions. So finally, so this is our equation for A. Okay. So finally, this will be equal to minus 1000 x5 over 60 minus by 250 x4 because 1000 divided by 4, right? It's equal to 250 plus by 324123x plus by C4. Okay. So now you also can find C4, or we can find C4. So we're going to substitute when x is equal to 6, y is equal to 0. We're going to substitute into, we're going to call this equation number 5. Okay. So this is equal to 0 is equal to 6 power of 5 times by 1000 divided by 60 is equal to minus 129600. Let me do it again. 6 power of 5 times by 1000 divided by 60. 129600 minus by 250 times by 6 power of 4. 324 123 zeros. Let me do it again. 6 power of 4 times by 250. Okay. And then plus by 324 123 times 6 equal to 194 1, 2, 3 plus by C4. Okay, so therefore C4 is equal to minus 1296, 12 minus 324, 123 plus 1944, 123 is equal to, so positive bringing it over is equal to minus 1.4904 times 10 to the power 6. Let me do it again. 129,600 minus 324, 123 plus 1944, 123. Hey, I think I got it wrong. Go on. Minus 129,600 minus 324,123 plus 1944,123. Oh, it's correct. 1 minus 1.4904 times 10 to the power 6. Let me write properly, okay? Minus 1.4904 times 10 to the power 6. Okay. Positive bring over negative. So therefore, EIY as a function of x is equal to minus 1000 x5 over 60 minus by 250 x4 plus by 324 123x minus by 1.4904 times 10 to the power 6. Okay, and we also found our EI theta as a function of x is equal to, did you find that? Oh, we found that already. It's equal to the same one. Okay. So I told you guys, right? Nothing but integration, knowing your boundary condition. Okay. So what I'm going to do, I'm going to stop here. Okay. And I'm going to end the class here. Okay. So,
Eugene,
yeah.
Just a quick question. Why is equal to 0 when x is equal to 6?
Because there's no deflection. Ali, there's no deflection when x is equal to 6.
And this is, I think this is going to be more complicated when we're going to calculate for the simply supported beam, yeah? Because there's going to be a deflection and it won't be equal
When
to
it's
0.
simply supported, okay, good question, Ali, good question. When simply supported, the boundary condition changes. So if it's simply supported, right, x is equal to 0, x is equal to L. V M theta y. V M theta y. This is what that will change. Can you see the difference? Can you all see the difference when it's simply supported? Right? The boundary condition changes. Okay. Then again, mathematically, you have to, the answer will be different. Does that make sense? Does that answer your question, Ali? Opera!
Eugene, I missed the explanation using the deformation pattern to figure out the boundaries for theta and y.
You missed the what?
I missed your explanation. Like, why is it like 0 and 0? Can you please explain why? Just like for this example that we just finished.
Or which example? Simply supported or cantilever?
Cantilever.
Y is equal to 0? Theta, right?
Yeah, why theta and y are equal to 0? I missed that explanation.
Can you watch the video, Opera?
Okay, I'll still watch it.
No, I'm just kidding. So y is equal to 0, deflection is equal to 0 because point B cannot move, right?
Right.
Right? Point B cannot deflect, it's drilled into the wall. Y theta is equal to 0 because the slope is equal to 0. See, all these I'm highlighting are the slope, yes or no?
Right.
At point B, slope is equal to 0.
Okay, thanks.
That's the only reason.
Thanks, I missed that.
Yeah, I knew it. You are sleeping, you know, unfortunately.
Sir,
Okay,
sir,
you were smoking something to make you high, right? Unbelievable.
I have a question.
Yes.
So, sir, in the simply supported beam, so if our y is 0 on both ends, then the theta should be 0 in the both ends too, right? Because it's not
No.
moving.
Ah, I like that. When y, so when y, okay, so if I'm going to draw the deformation pattern, that is a very good question. This is how the structure is going to deform. Right? So if I draw a horizontal line, the slope is not equal to 0, right? Slope is not equal to 0, yes or no?
Yes, sir. Yes, sir.
Yeah, good question, okay? So does not mean when x is equal to 0, theta is always equal to 0. If it's simply supported, that's not true. Good question, I like that, okay?
I think so. Yeah.
Okay, so I'm going to stop here. I'm going to take a short break for 5 minutes. We are going to do homework 13. Someone has one question, and I hope I can solve it. If not, I'll post the solution. But take a 5 minutes break and come back. Those of you who are done, you think you're okay, you can go. I'm not going to teach anything new. And I have a fantastic time with you guys. I know term test was tough one. Term test 2, you all did correction, you all did better. Final exam is still going to be the same. Same in the sense of what? 2 questions coming from where? Homework. Okay? Finish your homework, understand your homework, you will pass. Okay? You rely on the solution manual, I'm not so sure. Okay, give me a 5 minutes break. We come back, we do questions.